Hello and welcome to our Building Energy Codes seminar series. The series is based on our National Energy Codes Conference, which is hosted annually by the U.S. Department of Energy. We're here to present you with the latest in building energy codes, from developments in the model codes, to updates on what's happening across states and local governments, to highlighting tools and resources that you can take advantage of in your day-to-day practice. We'll be hearing from a number of leading experts about the challenges they're facing, ways they're working to solve them, and how their efforts are building the energy efficiency, comfort, quality, and affordability of America's homes and businesses. Join us virtually every week for important topics and interactive discussions, and help us continue the conversation. To learn more, visit energycodes.gov.
Welcome, everybody. We're very happy to have participants from around the world today to talk about building energy codes. I'm David Nemso, and I'm director of the Building Technologies Office at the United States Department of Energy. And because we are working with folks from around the world today, I need to say to you good morning and good afternoon and good evening, depending where you are. And I know many of you bent your calendars to be with us today, so I thank you for that. Let me tell you, we have a busy time here, and let me tell you what we want to accomplish. First of all, the role of building energy codes seems to be increasing in just about all over the world. And in the European Union, it has become an important, building energy codes have become an important part of the EU's approach to dealing with climate. In other countries around the world, there's increasing attention to building codes, especially as populations grow in countries such as India and Brazil and many others that haven't traditionally focused on building energy codes and now are. And I'll speak to the United States, in which building energy codes have always been an important energy policy tool. And we especially note there may be some changes in the near future. Candidate Joe Biden, now President-elect Joe Biden, talked extensively about building energy efficiency in the campaign. It's rare in the US to see this issue of building efficiency raised to the level of a presidential campaign. And it did. And he also talked in the campaign documents, emphasized the model codes, as well as training and implementation by state and local officials. So as I say, around the world, we see increasing attention to building energy codes. And so we wanted to organize today's webinar and discussion to get some highlights of that. Of course, we can't begin to cover the many important developments in this period of time, but let's see what we can do. We're combining today two procedural activities. One is the U.S. Department of Energy's annual National Energy Codes Conference. And we do this every year, and it focuses primarily on the United States. And many of you, I know there are well over 100 people on our webinar today. Many of you, primarily from the U.S., have participated in our meetings over the years, our conferences in Chicago and in Denver, et cetera, as we look at important activities in the codes field. And for those of you who are not Americans, the U.S. is, of course, a federal country, and so most of the action for us occurs at different levels. There are national and federal activities in building energy codes. There are model energy code bodies, but the adoption and implementation of energy codes and all building codes in the U.S. are primarily at the state level with enforcement with local governments. And this year, because of the COVID pandemic and our inability to have our National Energy Code Conference in person, we're having a series of sessions once a week, every Thursday. We're not doing it this week. We're doing it on a Tuesday because of our Thanksgiving holiday in the U.S. in 2 days. And we've gone through a host of issues that have been, I think, very interesting and very insightful. And today we're looking internationally as part of the Codes Conference. At the same time, there is a group active in the International Energy Agency, the IEA, which of course is the body that was created after the OPEC oil embargo in the 70s of the energy consuming countries to share their expertise and policy approaches. And the IEA, based in Paris, has established a working group called the TCP in IEA language, but it's called Energy in Buildings and Communities, with experts from different IEA member countries talk about issues of shared interest. That EBC committee, in turn, established a building energy codes working group within it to focus on this issue within the built environment. I'm chairman of that International Energy Agency Building Energy Codes group, and it's co-chaired by Michael Dunn of New Zealand. And so our Building Energy Code Working Group has had a series of webinars over the last year. Many of you have participated in those and looking at, again, important issues in global building codes. So today we wanted to have a joint meeting of the two groups to go over these issues. So I hope the state and local and other American code officials who are participating today will learn and be inspired by what you will hear from Canada and Italy and Singapore and around the world. And just as I hope those of you not from the US will learn what we're up to in the US, including from New York City and elsewhere. So that's our goal today. We want to have a conversation. We have a different format than typical. We're not having a single panel and then discussion. We're having 4 different sessions, and so you're going to have to be ready for that. Don't have time to go through everybody's bio. Allison Delgado will paste people's bios into the chat function if you want to know. But we're going to have 4 sessions today, as you might have seen from the agenda. First, we'll have an overview of codes from around the world. Then we'll discuss how codes are changing with changing climates. And that primarily means warming climates, but there are other changes to the climate around the world, of course. Then we'll have a session on net zero energy building initiatives and how that intersects with building energy codes, with net zero buildings. And finally, we'll take a look at the essential but very challenging issue of how we use building energy codes for existing buildings. And what we're organizing is a question and discussion following each of those sessions rather than a big one at the end. So be ready. And as Allison said, please put your any questions you might have into the chat function, and we will go from there. I also want to say before we get started, I want to thank the many people who organized this event, including Allison Delgado of Pacific Northwest National Lab in the US, Meredith Evans, also from PNNL in the US, Jeremy Williams from the US Department of Energy, and many others. So first, we're going to start today hearing from Meredith Evans of the Pacific Northwest National Lab. Meredith is a senior staff scientist at PNNL and is a leading expert, perhaps the leading expert in the US on international building energy codes and their development and their implementation. So Meredith will give us a survey from around the world. It's a big planet, Meredith, so why don't you get going? Thank you.
Thank you, David, and welcome everybody. We're really happy to have this joint session. We think it's really exciting to be able to share the experiences from both the US and around the world and start a conversation. As David said, I will provide a brief summary of some of the different flavors and themes you see with building energy codes around the world. With the hope of giving you a slightly broader picture than you're going to see in the flash sessions that follow. But I'd also like to use this opportunity, if any of you are interested in following up on these topics more, we'd be glad to hear from you. And the working group, as David mentioned, we have webinars, we'd be glad to invite you to future webinars. So with that, next slide, please. Looking globally, we can see that more and more countries are adopting building energy codes, and those codes have increasing coverage and stringency. So what does that mean? Countries, for example, like India, that 20 years ago did not have a building energy code, has one today. And it's working to expand the footprint of that code. So initially it only covered commercial buildings in certain states, and that has been growing to include residential buildings in the future as well. For example, the stringency all throughout the world is getting more robust as countries more frequently update their codes to incorporate new technologies, to take on more ambitious agendas regarding building energy efficiency. And typically it's very cost effective. So countries are quite sensitive to that, and they have various methods for calculating the cost effectiveness. And as a result, building energy codes are among the most cost-effective policies for energy savings and greenhouse gas reduction in buildings. Energy efficiency measures are implemented, with building energy codes. They're implemented during the initial construction, and they can provide benefits throughout a building's long lifetime. I should say that in some parts of the world, in particular in Europe, there are a range of different policies around buildings that are not that kind of interact with the codes themselves. And there are also attempts both in Europe, the US, and elsewhere to begin working on codes for existing buildings or to look at building performance. Next slide. So today the topics I will go through include net zero building energy codes, which is an evolving topic, compliance best practices, energy codes for existing buildings, adapting codes for hot and warmer climates, and integrating new technologies. What are some of the challenges? What are some of the opportunities? Next slide. So on the path to net zero energy, many jurisdictions are making commitments for net or nearly zero energy buildings in their codes. In the European Union, for example, all member states must have codes that mandate nearly zero energy buildings by the beginning of 2021. In California, and those, I should note that those buildings will be net zero, but also what they call cost optimal. So they are still looking at the cost efficiency of the measures that are required, but really trying to push the envelope in terms of the depth of the savings. In California, as many of you know, the energy code requires that all new residential buildings must be net zero energy starting in 2020, and for commercial buildings, that timeframe is 2030. There's a net zero carbon building for all initiative that the UN has launched last year as part of the under the UN Secretary General. So several countries have announced commitments for net zero carbon buildings as part of that initiative. Those include Kenya, Turkey, the UAE, and the UK. Australia and Canada have set trajectories towards zero energy. In Australia, they call it a zero carbon ready buildings, and in Canada, it's a similar framework that they are in the process of developing. So these are just a few specific examples. There are many others that we see all the time, both at the local level, the state level, as well as other countries that are working in this space. Next slide. Here you see, excuse me, improvements in the US ASHRAE 90.1 standard. And while this is not net zero at this point, you can see the trend over time. And this is true with other countries as well, where you see stepwise improvements in the code every couple of years, where it becomes more and more stringent, leading towards much closer to net zero, so that net zero is becoming much more attainable in countries than it would have been, say, 15 or 20 years ago. Next slide. So why does net zero energy matter? We did some analysis to prepare for that UN initiative, looking at what would happen, if you have a 1.5 degree scenario, meaning we have enough policy measures in place globally to keep climate change to a maximum of 1.5 degrees of increase from pre-industrial levels. How much energy can you save? So if you have a 1.5 degree scenario policy, without building policies, that's the top line, you would save, you can see or you would consume, I'm sorry, the gray line level of energy. If you add in building codes, you drop that significantly. So that means you actually achieve much fewer emissions, and you significantly reduce the cost as well. And then the final line, the blue line, is if you do all building policies. So you can see the importance of working towards net zero buildings in terms of the overall global framework for reducing emissions and improving our energy use. Next slide. Of course, a building energy code only works if you implement it. So compliance best practices are one of the things our working group has spent a good bit of time looking at and trying to share best practices on. Some of the things we note from the different countries that are in the working group and that we've studied include achieving the potential of codes requires effective implementation systems. It doesn't just happen by magic. You have to figure out your institutional setup, who is going to do the checking, how. So effective compliance requires adequate resources, technical knowledge, capacity, and strong institutions. And that institutional setup can vary quite a bit across jurisdictions. For example, in some countries, there's a mandatory inspection of all buildings to be able to comply with the code. Let's see, if folks could mute, that would be great. Whereas in others, it's more of a sampling type of approach or a review of the documents, but not necessarily all the buildings under construction. Next slide. Allison, could you mute people? On training and capacity building is also incredibly important for compliance. People can't comply if they don't understand what they're supposed to do. And so different countries have different approaches, but in general, the range of training programs and the range of support mechanisms has grown substantially. So, these can run from training programs for local governments on the code requirements and how to ensure compliance. And examples of countries that have programs like this, and this list has probably expanded significantly even in the last year or two: China, Canada, Japan, New Zealand, Singapore, Spain, United States. Software and software training. Many countries do have specialized software for code compliance, and you can see if you have that kind of software, having training in it is also quite important. Code compliance resource kits that allow people on their own time to explore the ways and means of improving compliance. Many countries have developed those types of resources. In fact, almost all the ones that we have seen have some type of resource kits. There are also training and certificate programs for building inspectors, and sponsored university degree programs on building energy efficiency, which have been growing in recent years. Next slide. So moving to existing buildings are really important because, for example, the UN Environment and IEA estimate that roughly 65% of the building stock in 2060 in the wealthier countries around the world, the OECD countries, will be buildings that already exist today. And yet there's not an obvious point of compliance. The building is already built. It's harder to redesign it. So how do we get around this? How can we think about requirements for existing buildings and what can and cannot work? So many countries and jurisdictions have begun exploring this question, and there's some very interesting developments we'll hear later from both New York City and Canada in terms of some approaches that they're considering. A growing number of jurisdictions with existing building energy codes began to introduce, and by I mean, I should rephrase that, who already have building energy codes, have begun to introduce more specific legislation, including rules on performance. So that monitoring the performance of buildings and making sure that over time the buildings achieve what they were designed to achieve. Next slide. So adapting codes for hot and warming climates is important for two reasons. First, building energy codes began in cold climates. People were cold, they wanted to remain warm in the winter. Building energy codes help with that. But over time, more and more hot, countries with hot climates have begun developing building energy codes. Of course, the United States has both hot and cold climates, but we've seen in our working group many countries that are dominated by hot climates. Singapore, Brazil, India have also expressed an interest, and they recognize that the requirements may need to be adjusted somewhat for their climate. So they're interested in learning about that. At the same time, all across the globe, we are seeing higher temperatures and more extreme weather. And codes can play a role in helping to address that. There are some challenges in that. So for example, the analysis that you see that some of my colleagues did in 2016, looking at counties in the US and how new ASHRAE climate zones would impact them. And you can see quite a few counties would classify in a new warmer climate zone, which nationally would increase EUI by 0.18%, meaning if you adjust your climate zone, you can actually have a less stringent set of energy efficiency requirements, which is something as a country and as a globe we may want to consider. What is the best approach to handling this, and how do we best adapt codes? At the same time, with extreme weather, there are growing numbers of cases where you have power outages, or because of extreme heat, the grid is put, it's vulnerable. So we heard, for example, at our annual working group symposium last week, Japan described various approaches to enhancing their code to become more resilient to these kinds of extremes when they deal with typhoons or earthquakes and so on. So that is another area of research that we've seen a few countries start to look at. Next slide, please. And then integrating new technologies into codes. And this also, I would say, relates to developing codes that can meet extreme weather requirements as well in some ways. So countries around the world are grappling with the best way to integrate new technology into building energy codes. And it's important to take it seriously and carefully think through the implications. It's not that difficult to calculate what the energy value of adding solar PV onto your roof might be compared to insulation. But at the same time, the renewable energy that you've built in, the building integrated solar, may only last 15 years, where the building might last 60 years. So do you want to have full trade-off between those two? The same exists with biomass furnaces. In the UK, we've heard where they're allowed to install biomass furnaces and have less stringent envelope measures, but those biomass furnaces oftentimes start to break after even 5 years. So it's a policy question ultimately. And similar things with building lighting, HVAC, controls, and when you bring them into a performance-based assessment, if they don't last as long as the building envelope. At the same time, so you could think of, and certainly ASHRAE 90.1 and other codes do have backstops so that you can only trade off a certain amount as one option. But thinking through clearly what those thresholds should be and potentially adjusting them based on data is I think something that we've seen many countries around the world consider. And then there's the idea of new technologies. So integrating new grid interactive technologies and smart meters, for example, fuel cells, batteries, and plug-in electric vehicles. We had a presentation last week from a researcher in Japan who's described how they are trying to integrate these technologies into their buildings to improve their resilience in the face of the many disasters they faced in recent years. And how do you do that? How do you ensure that the rules are fair and think through the range of issues? So for example, with smart meters, people may be concerned about the privacy of their data. and how do you handle that? We had a great presentation from the UK looking in depth both at their policies regarding implementing and requiring smart meters, and the privacy elements, as well as the kind of data that they are able to get from that for researchers at a much aggregated level, and what that is telling them about their building energy codes. And some very interesting conclusions about the efficiency of new versus existing buildings, for example. Next slide. So a few concluding thoughts. Codes have a proven track record of cost-effectively saving energy on a large scale. And they work best when complying is the easiest option, which requires strong capacity, tools, and clear enforcement mechanisms. A code not implemented is not worth very much. International collaboration on R&D for building energy codes can play a critical role in speeding the development and adoption of best practices. Thank you, and I'd be happy to answer any questions, or we'd love to have a short discussion here.
Thanks a lot, Meredith. That was great. Jeremy, are there any questions we have at this point for Meredith? And while you're showing that, let me just say in the chat, I hope folks have access to the chat. Some folks have already put in information, including URLs for the IEA committee we've been talking about, the Building Energy Codes Working Group, as well as for the US activities. And if you have other information or URLs or new reports, whatever it is, please feel free to put those into the chat function so everybody has access to it. And of course, after this event, we will make sure that we will post all the PowerPoints, et cetera. And Allison or one of us will share the links with all registrants for today's event. Back to you, Jeremy. What do we got?
Sure. So we had a question from Ian McDonald, who was asking what the unit for normalized energy use for ASHRAE 90.1 is in the US. Actually, this was a question posed in the chat, but it was answered in the chat too. So Ed Carley from here in the US noted it was EUI, which is kBTU per square foot. And then Tom also added that that particular code development graph is normalized based on 90.1 when 90.1 was established. So you have a percentage improvement relative to that original version of 90.1, which I believe was back in the 1975 timeframe and has since improved by half. And so in short, they are both correct. But if people are curious what the particular UI data points are behind that graph, shoot me a message or Meredith or really anybody on the code team at PNNL. We'd be happy to share. And we'll be happy to share all the cautions and caveats that go with some of that data. It's a great graph, and we get a lot of questions about it. One other question.
You know what, Jeremy? They're only going to ask you what the hell a square foot is, since everybody wants it in square meters, of course.
That's exactly right. Maybe we could do them a favor and produce an international version of that graph preemptively here. So,
well, the fact that it's based on 100, I don't think it matters. It cancels itself out. And just really quickly, so David had posted the energycodes.gov link, and you can find a lot of the documentation behind that graph at that website. Sorry.
Yes, that is true. And on that point, Jack Meredith, if you scroll up a little further, posted the EBC content as well. So if you're interested in more information from either group, you'll find URLs for both in the chat. Meredith, I wanted to ask you, this is a question that came to me privately, so you won't see it in the chat, but I think it's a good one, what are some of the major trends that are driving code adoption internationally? You have some of the traditional drivers like safety and energy conservation or affordability. You have sort of new challenges that are in the middle of these things, which are performance-based codes, and then you have things like climate, electrification, and decarbonization as well. So in your work surveying across the different countries, have you seen any particular trends sort of rise to the surface as of late?
So I would say universally, it's the energy savings and the cost savings that come with it. All countries are interested in that and the associated improvements in energy security they can get. And then I think most countries recognize that they can reduce emissions as well. The emissions that countries care about may vary somewhat. So in the developing world, it's criteria pollutants, particulates, things that affect human health. You know, you have polluted cities and people want to try to address that. So if they have less coal, for example, that they're burning to produce power, people may be able to breathe healthier and live longer lives. Whereas in other countries, it really may be the climate driver that is first and foremost. People are worried about the carbon dioxide emissions and want to bring that down. Jeremy,
Gotcha.
do you want to? Yeah, go ahead.
Hey, Meredith, there's a question from Yap in the chat too. And Allison, if you can quickly unmute Yap, we'd like to give him the chance to ask his question directly here. Yap, can you hear us?
Yes, for those who don't know, Yap Hogeling is from the Netherlands, and he's a leading, not only a leading building energy codes thinker globally, but has been particularly active with the European Union's energy code development.
Thank you very much for the opportunity to react on this great presentation. Well, what we did in Europe in developing the energy performance of building standards use the performance-based approach, and we bring these standards to ISO as well in the 52000 series. And I want to stress that this performance-based approach allows and stimulates innovation, because you are not putting requirements on products in your building code, but a requirement on the final energy used by the building. And how you do that is up to you, what solutions you want to choose. Of course, this is not always welcomed by small or medium enterprises who want to sell products with a certain value that is easy to do. Now you have to use a holistic approach, and you have to really do your homework with the calculations of the energy performance. And I want to ask you also, this audience who is dealing with energy codes in many parts of the world, look at the ISO 52000 standards and see how you can apply them on national or regional basis as well.
Yeah, and I think that's a really great point. And moving to performance-based standards has really opened up possibilities to drive in more efficiency because of that flexibility. At the same time, I think it has to be paired with improved capacity, because we've seen in some countries, and I won't name names, but where they have adopted, they switched entirely from prescriptive to performance-based, and maybe not all their market is ready to do building energy simulation and to do it well. And so they can end up with buildings that are actually less efficient because they're not doing it properly. So I think the devil is in the details, and it is an essential movement switch, but it also has to be backed up with very strong capacity and review and so on and so forth.
Yes, that's very much appreciated. It is capacity building. You need tools, you need education for that. Yes, I agree.
Okay. Jeremy, do you?
Yeah, if we have time, we have a couple more here in the chat.
Squeeze one more in.
Okay, there's a couple that are that you'll see in the chat that are focused on zero energy, and since we have that as a following topic area, I'm going to keep those in our pocket for now, because I think they'll be better positioned to the other speakers probably. But one is from Mr. Chen in the chat: are all new residential buildings in California being constructed to zero energy? Meredith, you happen to have the answer to that question?
My understanding is it's not all new buildings right now. The requirement is for, so it's 2020, but I'll admit I don't have the answer off the top of my head. I believe that they're getting closer, but I have not seen the actual data. I don't know if Ellen or Jeremy has.
Yeah, and Ellen or others, feel free to chime in if you have better information, but my understanding is they do have out year zero energy goal, but where the codes currently stand, they've made the move to require solar PV or renewable energy on homes for example, but I don't believe they're required to go to all the way to zero energy yet. They've taken the first step, presumably will take additional steps with further code updates.
And they are moving, it's David, they are moving in that direction, but they're also looking at zero net energy using a different methodology that's typical. I think it's a better methodology personally, but it's a different methodology in which they look at the time of use of the energy consumption in California. Because, right, if you think about it, the energy that's used at times of peak power production is typically less energy efficient because of the power plants and the transmission system, as well as tends to be, depends on the jurisdiction, but certainly in California, the peak power consumption has more pollution because of the nature of the power plants. So they're doing it on a time of use basis to try to make it work. And also, I'll just say, we follow many countries in the world, but the country known as the state of California does things in a very innovative and assertive way, and it is hard to keep up with all their innovations in energy activities. Meredith, thanks. As always, a great job, and as you can tell, Meredith is also the leader of the work on our working group. So please contact her about either the substance of that you heard from or specifics. You can contact her or me about the working group itself and going forward. Thanks, Meredith. Stick around. We're gonna need you today. Let's move to our first full panel, or first flash panel rather, developing codes for changing climates. And as we said earlier, it means changing climates in terms of weather, but it also means changing market climates, as you'll hear in a moment. So we have two speakers. We have Mr. Sihua Young of the Building and Construction Authority in Singapore, and they're very active, and the BCA is a dominant body in the Singapore codes world and building world. And Mr. Young is a principal manager of their environmental sustainability group there. And then we're going to hear from Dr. Ellen Franconi. Dr. Franconi is a senior research engineer also at Pacific Northwest National Lab in the United States, and has been active in many areas of building codes work, especially which she'll talk about today, how the codes are evolving a bit as technology and markets change. But first, and then we'll take some questions from you. But first, Mr. Young, are you on the line? Are you ready?
Yes, David. Can you hear me loud?
Yes, very good. Thank you. Welcome.
Okay. Thank you. Yeah. Good morning, everybody. I'm Young from Singapore. My presentation is about setting high efficiency standard for the central chill water plant and how to sustain the energy efficiency of the plant over the life of the equipment. How we go about setting achieving high efficiency standard, I think we have adopted a few measures. Next slide, please. First, we have raised the energy efficiency standard progressively over time by prescribing in our regulatory code as well as our green building rating code as new technologies and efficient components become commercially viable. Our regulatory code sets the minimum performance standards, while the higher standards are prescribed in our green building certification code, a green mark, which is a voluntary scheme introduced to drive a green building agenda. We have also moved away from equipment-based efficiency because we are reaching the point of diminishing returns from equipment alone. By adopting a system approach, we can push the boundary further and achieve a lot more energy savings. Next, to allow us to measure and verify, previous page, please. Yeah. Next, to allow us to measure and verify the efficiency performance of the plant while in operation, we impose a requirement that the system operating efficiency shall be determined based on accurate permanent M&B instrumentation installed on the plant and able to give an uncertainty within 5%. The measurement and verification instrument enable us to assess the system parameters real time to have an absolutely clear picture where we are and where we are heading to control the system component for optimized performance. Next slide, please. The third thing we do is to ensure that the building owner haven't installed an efficient plant, maintain them regularly to ensure operating at the optimum performance level. Therefore, our regulation requires building to conduct a 3-yearly audit on the chiller plant to ensure the efficiency are maintained to the minimum regulatory standards. The audit cycle will repeat 3 yearly until the next chiller retrofits. When an energy audit fails to meet the minimum prescribed system efficiency, the likelihood is that the component had not been properly maintained. What the owner needs to do is to simply carry out appropriate remedy and maintenance works to bring the plant efficiency back to its design or prescribed standards. The 3-yearly energy audit has its limitation as well. It may result in a sawtooth pattern of stepwise adjustment at the end of every audit cycle. A better approach is to adopt continuous commissioning as an ongoing process to maintain and improve occupant comfort and optimize energy use. From next year, BCA will be rolling out a new chiller efficiency smart portal that will enable the real-time continuous remote monitoring of the efficiency of the plant in the building. The system has the capability to perform trend analysis, detect performance, cooling load variances, as well as sensor drift. It will be available voluntarily. Building owners who link their chiller system to our smart portal will be waived from complying with the 3-yearly physical audits. In summary, having a stringent standard for chiller plant is an important step to address building efficiency in the tropics. Next is to implement a measurement and verification system for the long-term, continuous, and accurate tracking of the plant energy performance. Lastly, to adopt continuous commissioning as an ongoing process to maintain and improve occupant comfort and optimize energy use. That's the end of my presentation. Thank you.
Very good. Thanks for that. They're very helpful, and you invite several questions we will ask you. Let's hear from Ellen Franconi next. Are you there, Ellen?
Yeah, I'm here. Yeah.
Hi.
Thanks, David. I'm ready. You can start on my first slide, please. Is it there? There we go. Okay, great. The main message I'd like to share, my 5 minutes, is to say that if we want to address future energy trends with energy codes, we need to be forward thinking in their development. The case in point is to look at the future cooling. As you can see in the upper hand right chart, this is a chart from an IEA study from 2018, and it shows global cooling load in terms of carbon emissions. 2016 is the baseline. We see by 2015, per their assessment, it's nearly going to double. Yet, as you see in column 3, through going beyond business as usual policies and increasing efficiency of AC equipment, we can get back to 2016 levels, and we can further decrease emissions by decarbonizing power. But it's important to think about, well, what else happens when we decarbonize power? And we can look at what's going on in California to gain insights into that. As you can see, there's the California duck curve, and it shows the net load on the grid after renewables for a typical day in the last week in March. And it goes from 2012 down to 2020 projection. And as you can see, the renewable energy policies are working. They are removing fossil fuel generation from the grid. But in turn, you can see that there are these steep, increasingly steep ramp down and ramp up periods as renewable generation sources are coming on and coming off. So this presents some challenges for remaining a stable and a resilient grid. But buildings can help, and they have a big role to play. In the US, they consume 70% of electricity generation. So buildings not only have to have efficient air conditioning equipment, they also have to have demand flexibility, and they have to be interactive with the grid to support its stability and resilience. So on the left, I've outlined 7 basic strategies for trying to address cooling and other load increases and this need for efficiency, renewables, and demand flexibility. So step 1, it's very important to look at the end use first to reduce the load. And for cooling, this means improving the building envelope. I'm on the other slide, first slide, thank you. And also reducing heat gains, such as those from lighting. Then we want to increase steps 2 and 3 are increasing equipment efficiency and encouraging the installation of advanced technologies. Step 4 is making the most of on-site renewable energy sources. 5, 6, and 7, it all has to do with properly valuing the thing we want to accomplish. That includes demand flexibility, the time value of electric energy use or the time value of efficiency, and also account for carbon or other emissions metric. Next slide, please. Ooh, the suspense. I'll start talking. So you can see emerging is a table on the right. What it shows, I cross-reference those 7 steps against typical code mechanisms for demonstrating compliance. And the X's indicate for model energy codes, which is IECC 2018 for residential and ASHRAE 90.1 2019 for commercial, like whether that capability can be carried out within current model energy codes. So you can see that certainly the basics of codes, efficiency, prescriptive requirements, they can take care of driving down energy use. But when we start getting more to renewable energy and the valuing, that's a little bit more challenging, and that is being better addressed for performance-based compliance methods. And what's interesting about that, when you get to performance-based compliance, you're more able to use your own utility rates. And if those utility rates reflect the grid, then you can start counting for demand flexibility or the time value of efficiency. And also, as they do in California, have a time-dependent source metric, which can also be used and vary over the year. So in summary, if we want to be forward-looking in codes, we can use current code mechanisms to address load reductions and encourage the installation of efficient equipment and innovative systems. Advances are being discussed to incorporate renewable energy systems and starting to better value electric energy savings, demand flexibility, and carbon, but only in advanced codes so far in the US. But continued efforts are needed about how do we move from prescriptive requirements more to performance-based compliance, which allows more of a variable valuation and a regional valuation. And this goes hand in hand with this granularity that we need to better assess the value of efficiency or demand for a given grid region. Thank you. That's it.
Great. Thanks very much, Ellen. Jeremy Williams, do we have questions for Young or for Ellen?
I do, and I think the first question is for Young. It's in regards to M&V and the use of energy audits. And there's a similar question in the chat, and then I had another one that came separately. But the question is essentially why the focus on chiller equipment, and do the audits also take into account other end uses such as lighting or compressed air and ventilation?
Hello.
Yep, we've got you now.
Yeah. Okay, yeah. Actually, why we started with the central chill water plant, because typically in the tropic, it consumes up to 30% to 40% of the building energy, right? So it makes sense to look at this major energy use system to further save building energies. We're also mindful that other electrical systems also consume energy, such as the lighting, the lift, and so forth. In our current revision to our code, which we are doing now, next year we're introducing, we'll be mandating some form of sub-metering for the other building energy system, including lighting, air side system, hot water system, as well as a mechanical ventilation system. Yeah, I think that our industry has realized the benefit of metering. So we are going to put into our regulation, likely to introduce next year. Does that answer the questions?
I think it does, although there's a quick follow-up question which asks what the building owners do with the information from the audit. Is it just for, say, awareness, for example, or are they required to make upgrades to their buildings as a result?
They are required to comply with the prescribed standards in the regulations. So 3 yearly, the building owner will receive a notice to carry out an audit, and the audit had to be carried out by an energy auditor or a professional. And if the audit, the system efficiency doesn't meet the minimum standard, the building owner and the professional have to do something to bring back the efficiency. Yeah, this will continue until the plant retired or the next retrofit.
Gotcha. Okay. Thank you. I'm going to shift directions towards Ellen here because we've had a few questions come in for you, Ellen. Let's start with the general question, a policy-oriented question, which is what steps can be taken to more directly align policy mechanisms such as codes with a country's climate change or carbon reduction goals?
Okay, so one, I have seen even in the Biden energy plan a move towards getting net zero carbon emissions by 2050. And there also is a Clean Energy Jobs and Innovation Act, and that mentions a lot about targets and establishing national performance targets. And I think these two things do have to go hand in hand. And it's, again, being forward-looking in our code development, where we know the end goal, but it's not clear where we stand exactly and how do we get there in a way that not only combines emissions, but efficiency and demand flexibility. So I do think it's important to have a performance target-based approach in a stepwise fashion so that we can monitor our progress and kind of bring it all together to meet our objective.
Okay, and that actually, I'm going to squeeze in one more here, which I know is tough to do because this question is actually at the heart of a lot of the work that you've been working on at Piano now, but it picks up on something you just mentioned, which is demand flexibility. And so can you give us a little bit more detail on how better valuation of demand flexibility and some of the time-sensitive aspects that David mentioned earlier can be achieved in codes, at least from the US perspective, if not internationally?
Yeah, well, as moving more towards simplified performance-based methods or performance-based methods, does give us more granularity for doing better valuation. And it could be different metrics. So if if our utility rates truly do give a price as to the value of efficiency over time, a reflection of carbon, we could use rates, but we may need to have other metrics. So I'd say just moving towards better valuation methods, having them be more granular in aligning them with a specific target.
Okay, that's great. And David, I think you might have another question for Young. Is that correct?
I do. I have a broad one, Young, and I want to ask the same of our Canadian colleagues in a few minutes. Just tell us, the U.S. is a big country and we have many state jurisdictions. Our Italian colleagues who speak have the benefit of being part of the EU. But for a country like Singapore, as you develop your building energy codes, do you tend to do it solo, or do you work with there are other countries, either geographically in Malaysia, Australia, or Indonesia, that are in your part of the map, or do you work with other countries that you feel have similar building needs? Or just can you give us a little bit of that perspective from your country?
Actually, David, at the moment, Singapore don't have an energy code per se. We actually have environment sustainability code, where we look beyond energy, where we look at water efficiency, environmental protection, as well as health and well-being of the building. But energy efficiency is still a key criteria in our environment sustainability code. We also have various standards. We have standards for Singapore standard for air conditioning, mechanical ventilation system, lift, and lighting, and so forth. But they all come in separate standards, and we haven't unified them into an energy code. Of course, when if we want to embark into this, I think we will probably normally we'll have a overseas trip to US, to Europe, and all that. And we will want to understand about how the energy code for the country and how we can tailor back for the tropic environment. But in ASEAN, we have not seen any of our neighboring countries have come up with an energy code at the moment. So probably we'll withdraw from US once your energy code has come aboard, and we see how we can tailor toward a tropical climate.
Understood. Makes sense. Well, thank you both very much for your presentations. We need to turn to the next panel now. And our next panel will look specifically at net zero initiatives in building energy codes. And our first speaker today will be a professor, Dr. Vincenzo Corrado, who's with Politecnico of Torino, Turin in English, Torino in Italiano. And then we will hear from Canada. And we will hear, we will hear from Alex Ferguson. Alex Ferguson is with Natural Resources Canada. He's a research officer at CanMet Energy, which is Canada's federal energy lab. First, Professor Corrado, welcome.
Yeah, thank you, Mr. Chairman. I hope you hear me well. Good afternoon, good morning, good evening, everybody. I divided my 2 slides presentation into 2 parts. In the first slide, I will present the framework of the European legislation of energy efficiency of buildings. Can you skip to the new slide? Okay, and in the second slide, I will speak about the energy performance assessment of buildings. First of all, the European the European Union in the last years established some ambitious energy efficient targets for 2020, 2030, and 2050. As regards 2050, a roadmap of the Energy Union has been established, leading to a decarbonization of the whole continent. So, as regards the main provisions. A number of directives that you see on the left side of the slide have been issued in the last 20 years. You have some examples of these, including energy label, eco-design, energy efficiency, renewable energy sources, and so on. The most important of these directives, which is specifically focused on the energy performance of buildings, is the so-called EPBD that was issued in 3 steps. The first was in 2002, then we had a recast of this directive in 2010, and it was finally revised in 2018. This directive defines a number of new concepts and also requirements. First of all, it is based on an overall energy performance approach. It means that the building is considered including both fabric and technical building systems, and including all energy services in the building, from heating to cooling to lighting and so on, and also taking into account both the external climate and needs from the occupants. A new concept introduced a couple of years ago was the concept of smartness. So an important part of the energy performance depends on the smartness, and there was a provision to define a smartness readiness indicator for new buildings. Moreover, the EPBD introduced the concept and the obligation of energy performance certification, which is a very important activity aimed at transparency in sales and rents of buildings. But as regards the energy performance requirements, the most important concepts are, on one side, the cost optimality, and on the other side, the concept of NZEB, nearly zero energy building. Cost optimality just means that member states have to define the energy performance requirements for new and for buildings subject to renovations, considering packages of measures that minimize the global cost. So it is an important concept because it is in favor of the, let's say, economical optimization seen from the view of the final user. The other concept is the concept of nearly zero energy building, which has a very general definition. It is a very efficient building which has a very low amount of energy consumed, provided by a large amount from renewable energy sources. It means that it is up to national states to decide how to implement the directives through national operative laws. This is an important potentiality because it allows to take into account specific points linked to economical aspects, weather aspects that are different from one country to the other, but it is also a risk because there is a possibility of having an uneven or an ineffective implementation of the directive. An important focus is on renovation as well. Member states are asked to adopt national long-term renovation strategies in the next years. Can you skip to the next slide, please? The second and last slide is about energy performance assessment. On the left side, you see the scheme from Mr. Ogeling that made a question before, which presents the huge activity performed in the last 20 years at European level within CEN technical committees, but in the recent years also at ISO level, so from a joint collaboration between CEN and ISO. Many standards have been issued dealing with product characteristics, energy needs of buildings, energy use, and finally, the most important concept is the concept of overall building energy performance. Basically, the energy performance comes from an energy balance, taking into account delivered energy and exported energy, and energy produced on site from renewable sources. It is, of course, a weighted summation that takes into account primary energy factors. Some key issues arise when analyzing these standards. First of all, the importance of a correct definition of the energy assessment boundary of a building. Then the concepts of delivered energy, on-site produced energy from renewable sources, exported energy. Of course, also the primary energy conversion factors, it's often up to single states to define these factors. So it means that there is a risk of having very different results, not because of a better or worse quality of the building itself, but because of political reasons. And finally, the concept of share of renewable energy. On the right side, you see a figure in which different perimeters are distinguished. You have the building on the left side and the on-site systems, which are within the energy assessment boundary of the buildings. Then on the right side, you have everything it's outside the building, and there is a differentiation between what is nearby and what is distant. So these are very important concepts which are presented in ISO 52000, which is, I think, the most important international standards as regards the energy performance assessment, considering an holistic approach. That's all from my side, and of course, I will be glad to answer to any question.
Thanks, Professor Corrado. Well, go back a slide. I'm going to take the moderator's liberty to ask you a question. So the very last point you made about what is close and medium distant and more distant, does this approach make any distinction when an entire neighborhood or community is built, whether that community can be treated as one energy unit, or it's merely the building and then everything else?
I mean, what is nearby? I think if you have, for example, a small district heating system, which is fired by, for example, a cogenerator, which serves a group of buildings or a community, it is to be considered as a nearby perimeter. But if you get electrical energy from the national grid, of course, it is to be considered as a distant.
Sure.
Of course, there is much flexibility because it is up to national annexes to the standards in which different states can decide how to take into account the different perimeters. So maybe in Italy, there is no distinction between nearby and distant, but another country could maybe decide to penalize or to favor different perimeters or different technologies or different kinds of energy vectors.
Good, thank you. Thank you very much. We will save other questions for you later. Now we will hear from Canada and Alex Ferguson. Are you there, Alex?
Yes, I am. Can you hear me okay?
Perfectly, thank you.
Oh, fantastic. I'm actually calling from a spot with pretty spotty reception, so I'm glad to hear I'm connected okay. So yeah, I'm talking a little bit today about net zero codes in Canada, and specifically some of the observations that we made when we worked on the analysis around Canada's recent tiered code. Meredith earlier mentioned, she talked a little bit about Canada putting itself on a trajectory towards net zero codes or net zero ready codes. And she's referring to work by our province of BC, and then also subsequent and more recently at the federal level, where we implemented a tiered approach or a stepped approach, the highest of which targeted 70% energy savings in residential and commercial buildings, and aligned more or less with where net zero ready or passive house standards are in Canada. And it was interesting. It was an interesting process to go through the development of that, because the debates around the code related to questions that we anticipated, questions about affordability or questions about what level of performance targets should be the ones that are codified, They talked quite a bit about cost optimization and trying to figure out what the best target would be. But we also ended up talking an awful lot about how you measure energy use in buildings, and specifically the debate between the EUI approach or the current reference house approach or reference buildings approach. And Canada, for the last decade or so, most of the codes here in Canada have used the reference building approach. So a building is constructed according to the prescriptive requirements of code, and then the performance standard has to beat that house by 20% or by an X amount of percentage or more to demonstrate compliance with code. And through the development of this code, we heard from a lot of people, a lot of stakeholders and interested parties that were adamant that an EUI-based approach would lead to a more efficient code, would be an easier code to understand, and would definitely provide would give us a code that would give us better, more effective housing design, building design, as well as more measures in the buildings. So that's really what I wanted to talk about a little bit today, because when we started going into the process of developing that code, we realized that the application of the EUI-based codes is not at all straightforward, and that there could be significant challenges from time to time, or in some cases, unexpected consequences or unanticipated outcomes that could amount to that when we compared it to the current way we're doing things in Canada. And if you could just stand to the first slide, my screen has dropped off, but I think you should see a map of Canada colored by climate zone. And one of the things we found is that because Canada has a very diverse set of climate zones, we extend from sort of moderate temperate to higher Arctic locations with 10,000 plus heating degree days, that as we look at how the code gets implemented across those climate zones, we can see the different approaches lead to different outcomes. If you go to my next slide, you should now see a little table describing the types of outcomes that you can expect with the reference house approach versus the EUI approach. And what we found when we looked at the reference house approach, we're basically ensuring that all the homes in the climate zone have similar levels of thermal resistance, similar levels of insulation and fenestration, as well as whereas the EUI would ensure that all the homes in that climate zone had similar levels of energy consumption, at least when aggregated over a floor area. And what we found is that what that means is that when you look at the range of the climate zone, which spans about 1,000 degree days in heating load, what we see there is that with the reference house approach, the buildings towards the colder end of the climate zone, or the upper edge of the climate zone, tend to use more energy, versus with the EUI approach, the homes have similar energy use across the entire climate zone, but homes in the climate zone near the edge of the climate zone in the colder parts tend to be built to more stringent energy requirements. And that can lead to some funny consequences. So if you go to my last slide, you should now see a table that plots on the vertical axis the thermal energy demand index, or a heating intensity factor for the homes, and on the horizontal axis, a range of heating degree days. And every dot you see there is a home located in a different community across the country. And we see that as the weather gets colder, as we expect, the loads and the energy intensity increases. The red lines indicate sort of nominal targets for an intensity-based step code across Canada. As you can see, as you go to higher levels, more cold locations or colder climates, those steps gradually increase. And then what we notice near the boundary of the climate zone is, in many cases, we have locations in Canada that are geographically quite similar. In some cases, they could actually be quite close and maybe only separated by a couple hundred kilometers, but they end up in different climate zones. And that means that they have very different energy budgets under the EUI approach. And not only does it mean it has very different energy budgets, but there's a bit of an unexpected consequence that comes in here, where the home in the warmer climate zone faces the more stringent budget, and then also faces a greater onus to insulate or to add energy efficiency measures. So if you look right here in the middle, there's an example in orange of Toronto and Kingston, or Greenwood and Yarmouth, and those are locations that are geographically quite close. But we see that the home on the warmer side of the climate zone is actually going to end up to be a better insulated and a better sealed home and a more expensive home to build than a home on a colder climate zone. And so that's one of the reasons why when Canada put together the STEP code and our recent tiered code, which we're trying to adopt into our national codes as we speak, we've elected not to adopt the EUI-based approaches for the time being. I think that most of the stakeholders around the code would tell you that they don't regard this in any way as a settled issue, that in many cases there's a lot of shareholders, a lot of stakeholders and a lot of interested parties that are strongly pushing Canada to move towards to an intensity-based code. And it's a topic of further research of how we can adapt that approach to maybe better reflect some of the realities or the outcomes that would happen as we apply it across our country. But it certainly remains an area of additional research and where more work is going to be required in the coming years. And that's what I had to share with you today.
Great. Thanks, Alex, for that. And you also underscore a different point that that there were several federal countries on the call today who deal with subnational issues, including yours in the U.S. and Australia, and I don't know if Brazil's on the call, et cetera, et cetera. So thanks for helping us think that through. Jeremy, what questions do we have for Vincenzo and Alex?
Sure. So Dr. Franconi has a question for Dr. Corrado. So Allison, if you can, do you mind unmuting Ellen Franconi briefly?
Will do. Trying to look for her in the list.
Yeah, no, I think I got it. Can you hear me?
Yeah. Yes, we can.
Okay. Yeah, I was wondering if Dr. Corrado was familiar with efforts to develop standardized definitions and simulation procedures around energy flexibility in buildings. I think it was the European Smart Building Initiative that might have tried to tackle that.
Yeah, I answered you privately. I've heard about it, but I'm not directly involved in this initiative.
Okay, yeah, I see your response. Thank you.
You're welcome.
Okay, and we have a second. Actually, we have a couple for Mr. Ferguson too. And I know we're getting a little tight on time, but let's try and work one in. Particularly, how has Canada's move to a single zone for the Energy Star program worked out, in your opinion? And then a follow on to that is do you think that approach will continue in Canada?
So first off, I want to say that I'm not a representative of the Energy Star program, and I don't think I can offer an opinion on its current efficacy. But I do note that across the country, when we see diversity of climate zones, they require diversity of approaches, and a single approach, generally speaking, is not terribly effective in terms of ensuring effective and appropriate solutions across the ranges of locations in a country as big as Canada.
Okay, and let me tack on one more question too. So you mentioned net zero, which is the topic of this portion of the agenda. And so, what do you think, in your opinion? Let's say passive house targets, are they something that can be obtained across all of the different climate zones or all the different climates in Canada, let's say, or internationally for that matter?
Mm-hmm. That's definitely a really good question, and we did spend some time looking at this in Canada when we were contemplating various energy performance targets as part of a net zero or a passive house level performance. And we determined that when you look again across the range of climate zones that I showed earlier, it is extraordinarily it's relatively easy to achieve passive house targets in a more moderate or more mild temperature locations But because under the original passive house concept that the TEDI and MUI targets don't necessarily change with climate zone, it becomes progressively more expensive and progressively more impractical to construct buildings that meet those targets the further north you go or the further you go into colder and colder locations. And I think my colleague Ian McDonald, who I think is on the phone, looked at a study of doing passive house level performance in our northern territories and determined that the levels of insulation that would be required would be, I mean, though not implausible, would certainly be highly impractical. And especially when you consider that those homes also face other interesting intrinsic engineering challenges based on their climates that may meet some of the performance targets somewhat unwieldy and unachievable.
If I can add something, the passive house standard is more focused on insulation and on space heating. The concept of a nearly zero energy building as introduced in the European Union is more general and more flexible. So it has to do with the overall energy performance, including all the energy services. And moreover, it is very flexible considering different possible climates. This is the reason for which I think there is a high potentiality in applying this standard, the standard of nearly zero energy building.
If I may just add one more comment there. I would say, though, it's really important to acknowledge that whether you look at passive house, whether you look at net zero ready, whether you look at homes that are built to the highest level of the BC step code or that are built to the tier 5 of the upcoming national code, there's a lot of similarity and they all have a lot of their same fundamental building blocks inside of them. They all tend to be airtight construction. They all tend to have highly insulated envelopes to cut down basic heating loads, and they all tend to use efficient mechanical systems, and they all include central ventilation systems. So whatever lens you're looking at, those basic building blocks are intrinsic in all of them. Each of them has a slightly different philosophy that relates to how you design the building, how you measure its energy performance, and those philosophies can lead to slightly different outcomes or sometimes somewhat significantly different outcomes, as we saw with my analysis of climate zones. But whichever those flavors you choose, the basic components and the basic foundation towards a more efficient building stock, I think, is indisputable.
Great, thank you. We need to move on to the next panel. Obviously, we can keep going on that, and but thank you both. Let's turn to our final panel for today, our final flash panel. We're going to look at existing buildings. There's a lot. Why do we deal with existing buildings? Because there's so many of them. I can only do by memory my country. In the US, there are over 125 million buildings, residential and commercial, and we're building a little over 1 million a year, 1.25 million a year. So that existing building stock is enormous, as it is all around the world, depending on your pace of development and how big a share it is. So first, we're going to hear from Greg Fairthorne, who's with Natural Resource Council of Canada. He focuses on residential and small commercial buildings. And then we'll hear from Gina Bokra. Gina is the Chief Sustainability Officer of the New York City Department of Buildings. And Gina, I am not inviting you to talk about passive house, but I will note that what has been, I think still is the largest passive house high-rise in the US, if not the world, is in New York City on Roosevelt Island, a 26-story residential structure. But we were asked you to talk about existing buildings, not passive house. So Greg, first to you, please.
Perfect. Hopefully you can hear me.
Yes, fine, thank you.
Perfect. So I thought I would start my time today with a brief explanation of codes in Canada. So you can go to my first slide. So building code adoption and enforcement falls under the authority of the provinces and territories here in Canada. However, the federal government promotes harmonization through the development of national model codes, and the provinces and territories can adapt or adopt these codes as they see fit. The code development process is really a collaboration between the Canadian Commission on Building and Fire Codes, which is represented by the blue circle, and they're really the holder of our national code model codes. It's also a collaboration with the National Research Council and Codes Canada, which you see in gray, the gray circle, and the provinces and territories, which is represented by the green circle. So one of the main policy drivers pushing alterations to existing buildings forward is the Pan-Canadian Framework on Clean Growth and Climate Change. One of the actions identified within that framework is that the federal, provincial, and territorial governments will work to develop a model code for existing buildings by 2022. Now that date may be impacted a little bit by the COVID-19 situation globally. This code will help guide energy efficiency improvements that can be made when renovating buildings. So some of the overall goals and initiatives. So the main goal is to not to bring existing buildings up to current code. Rather, the goal is to close the gap between the existing building stock and new construction. So on its way to developing a policy paper, the CCBFC, which is the blue circle, formed a joint task group which was composed of members from the CCBFC, the blue circle, and the green circle from the provinces and territories. And their mandate was to define a scope or application for alterations to existing buildings, but also to provide a list of overarching principles that will guide the development of the technical requirements. So that joint task group decided that these requirements should apply to houses, small buildings, and large buildings, and that the scope should include all objectives of the code, so safety, health, fire protection, accessibility, etc., and not just energy efficiency. So the work of this group has culminated into a policy paper that communicates the overall approach or concept for alterations to existing buildings in Canada. And more detail will be provided on the next slide. This policy paper defines some triggers for consideration and includes a list of principles to follow. So the first principle is to close the performance gap, as I was mentioning, between new buildings and existing buildings, to maintain or increase life safety and overall building performance, so you can't make a building worse when doing an alteration, to avoid negative unintended consequences, to ensure when a repair or maintenance or alteration is in progress that the building is not left unsafe, to be reasonable, practical, and effective, be flexible to encourage alterations to existing buildings rather than to place undue burden on the public. Also to be flexible for heritage elements and heritage buildings, and that they should complement voluntary programs and other policy tools. So we can move to the next slide. So this slide shows the approach that the policy paper has developed. So first we start with a situation where a building owner or person may have to ask themselves, what is my alteration? Is it a maintenance and repair replacement program? And if the answer to that question is yes, then you can see on the left side of the flow chart here that the building owner would move down to this exempt category, which is represented by the green box. The one caveat for being exempt, though, is to ensure that the maintenance or repair project does not make the building worse. Now we head back up to the top of the flow chart. If the answer to the question of whether this is maintenance or repair is no, then there are some categories that were developed for consideration by any building owner. So you can see them here. They are system upgrade. Is your project a system upgrade, a space reconfiguration, a change of occupancy, an addition, or is it something else? And that's just designated by other. So if your project is not exempt, then it's likely to fall into one of these project types. From here, these projects would trigger further examination or a decision point on whether the project falls under one of two additional categories. So is it a minor or a major alteration? And this depends on the scope of the alteration. So I should note at this point that the current code will not necessarily apply to both, or sorry, the current code does apply to both minor and major alterations. The key question is the extent to which the current code requirements apply and what relaxations are given. And most of the technical work, which is not quite underway yet, will be about answering this question in accordance with the principles. So you also see here at the bottom of the flow chart that it illustrates the extent to which the current code may apply for a minor project. So it's the project area only. And for a major project, it would be all directly affected systems. So currently the work on alterations to existing buildings is slowly transitioning from the policy stage to the development of technical requirements to be published in the code language. And that's where we sit today. Thank you.
Very good. Thank you for that. Gina Boker from New York City, please.
Good morning, and good afternoon, and good evening across all of our attendees. Can you hear me okay?
Yes, Gina, thanks.
Excellent, thank you. I'm Gina Boker from the New York City Department of Buildings. If we go ahead to the next slide, I'd like to explain our overarching policy goal in the city of New York, which came from a law in 2014 and aligns us with the goals of the United Nations. Was to achieve a reduction of greenhouse gas emissions in New York City 80% by 2050. And as you can see in this chart, a large portion of our greenhouse gas emissions in New York City are from our building sector, which is, probably the problem that most large urban areas are addressing across the globe. So we need to achieve drastic reductions in our carbon emissions from our building sector. The emissions reductions that we've achieved over the past years, beginning back in 2009, have largely come from fuel switching. So we have to do something more aggressive. And the background on the policy evolution in New York City was that we started off with some existing building policies in 2009. And what we have seen over time is that owners are not making voluntary improvements to their buildings, despite having a mandate for energy consumption disclosure on an annual basis, and despite having a law that requires owners of large buildings to do a energy audit and retro-commissioning of their building once every 10 years. And our energy code, as aggressive as it is on the side for new buildings, isn't affecting existing buildings in the way that we need it to. So we had to come up with a new policy approach to encourage owners of buildings, existing buildings, to change performance characteristics over the coming years. And we have about 1.1 million buildings in New York City. So to give you context for the laws that I'm going to be talking about, we are going to be targeting our largest buildings in New York City, those that are 25,000 square feet and greater. And I guess that's about 2,300 or so square meters, with a suite of laws that passed last year. So if we go to the next slide, I'll focus most of my time on the Climate Mobilization Act. And these laws passed last year in April of 2019. And I'll talk about four of the primary pieces of legislation just very quickly. In New York City, all new roofs now have to have either a green roof or they must have solar panels on the roof. And that mandate does cover some existing buildings, only when they're replacing the roof down to the structure. Another legislative change was that our benchmarking law evolved into a public disclosure law where energy grades are now displayed in the lobby of large buildings. And again, it's those buildings that are 25,000 square feet or greater. So it's about 40,000 buildings out of the 1.1 million in New York City that now have to disclose their energy performance in the form of a letter grade so that the public can see that whenever they go in and out of the building. So that's helping owners or occupants become much more aware of the performance of the buildings that they live in or work in. I also need to mention a law that passed that authorized PACE financing, or property assessed clean energy financing, because we are aware that obviously one of the major challenges for owners is being able to pay for upgrades to their buildings. PACE financing authorized long-term, no money down loans that pay back through an owner's property tax bill. And the loan is tied to the building, not the owner, which eliminates the disincentive for an owner to avoid making any kinds of improvements to their buildings if they're planning on selling that asset. So that's a major accomplishment for the city as well, because we need owners to have leverage to capital to make improvements. But the star of the Climate Mobilization Act, or some also refer to it as the Green New Deal in New York City, is the emissions limits for large buildings. So we have actually passed a requirement that sets a cap on the emissions from a building. Again, we're dealing about 40,000 buildings in the city, and they probably account for close to 60% of the greenhouse gas emissions from the building sector. So that's why we're targeting those large buildings. This sets emissions limits for buildings beginning in 2024. It's based on the type of occupancy for the building. And in 2024, we estimate that about 20% of buildings will not comply with the law. If they don't meet the law and the emissions caps, the fines are extraordinary. Sometimes for an owner, it could be in the millions of dollars on an annual basis. So the fine has been set to discourage owners from paying the fine and instead work to improve the performance of their building. And now the limits drop in 2030. They are lowered, and at that point, if owners hadn't made any improvements to their buildings since the law was enacted, we anticipate about 75% of owners would not be able to meet those emission caps and would be subject to a fine. And I just want to, from a technical background, explain that the emissions limits are greenhouse gas per square foot. So it's a greenhouse gas intensity metric that we're using to measure buildings. There are a lot of challenges with that. It's also a source carbon coefficient. So we're asking owners right now to look at how their building behaves on the grid and what types of energy sources are being used in the building. Not all of the details got worked out in legislation. It's quite complex, and I've simplified it here. But there is an advisory board that will be working over the next year to help us fine-tune the law and address some of the challenges that were not worked out before the legislation passed. The law allows things like renewable energy certificates and limited use of greenhouse gas offsets. So an owner can do some things to supplement the performance of the building and, time some of the improvements they're making with their capital planning. And so just to summarize it, the major drivers here are really energy efficiency in buildings and load reduction, because you can't meet the requirements of the greenhouse gas emissions intensity limits without having an energy efficient building. It's also trying to drive load flexibility in buildings to make them good grid citizens. And it also goes hand in hand with initiatives and objectives at the state level to clean the energy grid for New York State and particularly for New York City, which is something that is, as you know, largely out of the control of the building owner. So that is a summary of the Climate Mobilization Act in New York City. And again, a lot of the attention is going to our emissions limits that we have set for buildings. And I look forward to any questions anyone might have.
Great. Thanks, Gina, for describing what New York City's up to. Let me go first. And we've gone now 104 minutes and have not, and the coronavirus pandemic has not come up, which is pretty shocking in 2020. I'm sorry to say. So, Gina, just a quick question, or same to you, Greg. In terms of, I don't know if this is about substance or politics, but has the pressure, has both the changes to buildings because of trying to mitigate coronavirus exposure, as well as the financial pressure on building owners, have you gotten any reaction to the building code because of that? Is there any nexus or not particularly?
I'll go ahead and tackle that first. We're definitely getting questions from owners. There's, a perception that there's a conflict in our energy objectives and those things that might help keep us safer in an indoor environment, like increased ventilation. But we, largely asked owners to think about how the coronavirus has presented opportunities that we may be able to solve concurrently with our climate change challenge, and identify those solutions that work to address both crises. And we're certainly learning some things about buildings that are largely unoccupied in New York right now as we're going through this together. And we're finding that the energy reduction doesn't reflect the reduction in occupancy. So that is teaching us that there are some things that we can do better to manage our buildings. And it's a great learning opportunity that we all wish we didn't have, but we will look for the best lessons learned as we can.
Yeah, and I'll just add from at USDA, we were looking at what you just said, and for us, we think the key issues will be, one, mitigating any energy penalties that come out from increased ventilation rates, and two, and I'm thinking also about Professor Corrado's, no, it was an earlier point, I think it was Young, about continuous commissioning and whether commissioning and retro commissioning is one of those tools where we can serve both goals of better functioning, healthier HVAC, as well as more efficient HVAC. So we'd like to work with you and any others on that issue. Jeremy, what questions do we have for Gina and for Greg?
Yeah, we have quite a few here. Let's start with Greg. Greg, so you had referenced the Pan-Canadian framework as a major driver. And so I guess the basic question is, it deals with why alterations to existing buildings was not limited to improving energy efficiency in buildings only. So hopefully that question makes sense. If not, let me know and I'll try and clarify a bit.
No, it makes sense. I think that was certainly a starting point for during the policy discussion, was the energy efficiency. But I think as that joint task group continued to develop, some of the policy items, it became clear that in doing an alteration, it really does start to affect other components of the building. And part of the principles is to ensure that, you don't create any unintended consequences. So that's really where it started to expand from the starting point for focusing on energy efficiency and into some of the other objectives of the code, like safety, fire protection, accessibility, and so on.
Okay, and there's a follow-on question there. So you just mentioned things like, fire protection and safety. So with energy codes, we a lot of times hear about, comfort and durability, or even, health and productivity, to David's point regarding COVID. So I'm curious, did the Pan-Canadian framework, does it address some of those other areas as well, or maybe outside of the framework? What role did those aspects play in Canada's code?
I don't know that the Pan-Canadian framework necessarily addresses some of those other aspects. It is focused on energy and, reducing greenhouse gases and so on. But for the example with the coronavirus, it has started to have some discussion on, material properties. What are the types of materials that could be used in a building? Are there materials that are better used for sanitizing or even self-sanitizing, and so on? So those types of discussions are starting, but yeah, hopefully that answers that question.
I think it does. And there, I see Ian McDonald has put a URL in the chat as well for more information on the Pan-Canadian framework too. So just to draw everyone's attention to that. And I think we should shift to lots of questions for Gina in Local Law 97. So let's shift there and try and grab a couple before we have to wrap up here. But one to start us with, or to kick us off here, Gina, is can you tell us a little bit about what New York City's doing from an implementation standpoint, specifically helping building owners comply with the new ordinance?
Thank you, Jeremy. It's a great question. The city is actually launching a program to help owners with direct technical assistance. Many owners really don't know where to start. So they will help them understand sort of a deep carbon reduction retrofit path for their building and begin to help them find assistance for the types of strategies that will work for their building. Obviously, a lot of this is emphasizing electrification, which we have to figure out how to phase in over time in New York City. In addition to that, the Department of Buildings, we are reaching out directly to owners that have the highest emissions intensity per square foot. Sometimes the metric doesn't serve all building types or activities in a building as well as it does for others. And we have to help understand better what's going on in the building and how we can help the owner comply. The city's obviously not interested in having owners pay fines. We want them to improve their buildings. So there is a lot going on to provide direct outreach to them, connect them to incentive programs from utilities, connect owners directly to incentive programs that happen through the state. And it's we're really just getting started on it. Obviously, with 40,000 building owners to reach out to, we have our work cut out for us.
Okay, thank you. And there's another question that's come up too. And I know when we've heard you, this is a question that's come up, in some of the other presentations I've heard you speak on in the past, and that's, what's happening outside of Local Law 97. So what other mechanisms need to be implemented in order to make a carbon cap for existing buildings work?
Thanks, Jeremy. The legacy legislation that I mentioned is really very important for helping owners prepare and being able as a city to implement a carbon cap for buildings. We've had a benchmarking law in New York City for a very long time now. We actually have owners. The compliance rate is very, very high in the mid 90s. So owners are paying attention to how their buildings use energy in comparison to other buildings, and that's really essential to this type of legislation. We've also had the energy audits and retro-commissioning law in place, which gets to the next level of detail and helps owners understand about their own operations of the building, which is key and very important place to start, whether they can make improvements just to how they're operating the building before they start making capital improvements. So those types of strategies are very important to start out with. And it also helps that the state and the city are very much aligned. So the state also, after this law passed in New York City last year, the state passed their own, landmark legislation. Certainly in the United States, it's the most broad, sweeping carbon legislation that I have seen. And so the Climate Leadership and Community Protection Act at New York State, the CLCPA, is setting many of the same goals, which helps New York City achieve what we need to do, because we could make all of these improvements in our buildings, and if our energy grid didn't change, we wouldn't get there. We have to see a cleaner grid, and New York State has set really aggressive goals, which will help our building owners enormously.
Okay, and I want to try and sneak in maybe one last question here, because I know we're up against time, and then we'll hand it back to David. But last question, which is also for you, Gina. And the context is New York City was sort of first, or at least early out of the gate, let's say, in the U.S. And a lot of what you're talking about is being described by the industry increasingly as building performance standards. And so not only New York City at this point, but Washington, D.C. and St. Louis, Missouri in the U.S. have all looked at these types of policies, different variations. But it's also something that states and other cities in the U.S., as well as others internationally, are starting to take a closer look at as well, which is kind of a performance-based, just to sum it up in a nutshell, a performance-based perspective on regulating energy use in existing buildings. And so, Gina, if you had to give advice to others who are looking at what New York has done and picking it up and trying to come up with a variation of their own to work a building performance standard, what advice would you have for those others?
I definitely start with the programs that other cities have implemented. I know our mayor's office spent a lot of time in reaching out to other municipalities literally around the world to come up with a solution for New York. We're still learning from what other cities are debating, and I think the best piece of advice that I could give is based on something that I greatly appreciate about the law that passed in New York, as well as the law that passed at New York State, and that's that in both of them, they have mandated a period of time for investigation to make sure that we can fully implement the law successfully. Both have advisory boards of stakeholders across the industry to help figure out how we can do that. And both of them have a component of environmental justice so that we figure out a very fair way to make this work. So there is a lot of really great work out there to build on. And so I think that's the best way to approach it, is make sure that you're learning from other communities and that we're all working together.
Okay, thank you for that response, Gina, and thanks to all the panelists as well. It's been a really great discussion, lots of good questions. If you haven't been paying attention to the chat, give it one last look. There's been several comments building on some of the earlier questions we had, several links, more information too. So thank you to everybody. And David, I'm going to hand it back to you if you don't mind closing us out.
Thanks, Jeremy, and thanks all. Thanks, Greg and Gina, for that panel. So I want to say in closing, just a couple of things. One is the next upcoming sessions of the U.S.'s National Energy Codes Conference. We're going to return to a Thursday schedule. So we're going to do a deeper dive on some of the topics you heard about today. So I hope you'll join us. On December 3rd, we'll be looking at advanced technologies and how they fit into building energy codes. And we mean advanced energy technologies such as photovoltaics and electric vehicles, energy storage, buildings that are grid interactive and connected. And then on December 10th, we'll be taking a look at how building policies more broadly are evolving to look at a resilient, efficient, low carbon future. So those issues of beneficial electrification and decarbonization will be coming up. I apologize. Those are 1 to 2:30 p.m. Eastern time. So it was designed for a North American audience. So I apologize in advance to any Asian colleagues who may be hard pressed to make it in the middle of the night, but you're welcome if you can. And then I want to say for the International Energy Agency's Building Energy Codes Working Group, that we will be working over the coming months and year on several reports that the working group will be putting out, and where the ones we are working on right now are on existing buildings, on compliance, which is an issue which really so important, as you heard earlier, and really varies across jurisdictions and cultures, as well as new technologies. So we would love your input on those. Please contact myself or Meredith Evans or Jeremy Williams on that. And without further ado, I will thank our great speakers today, Meredith Evans and Sue Hawa-Young, Ellen Franconi, Vincenzo Corrado, Alex Ferguson, Greg Fairthorne, and Gina Bokra, and of course you, Jeremy Williams and Allison Delgado, for organizing it. Thank you all. If you're in the US, have a happy Thanksgiving, and to the rest of you, I hope you have a happy and safe time, and we look forward to working with you again soon. So long.
This has been the National Energy Codes Conference Seminar Series, hosted by the U.S. Department of Energy. Join us each week for a number of other important topics in building energy codes, just like today's. We're here every Thursday afternoon at 1 p.m. Eastern. Participate live in our upcoming events, or listen to past events on demand through our energycodes.gov training portal. There you'll find other helpful tools and resources, from education and training materials to compliance tools like our ResCheck and ComCheck software, to the latest on state code updates, to analysis of energy code impacts, from energy savings to cost effectiveness, and more. Check out energycodes.gov for those and a number of other technical assistance resources from DOE, Pacific Northwest National Lab, and others. From the DOE Building Energy Codes program, we hope you learned something new about energy codes and enjoyed today's session. Thanks for being part of the conversation, and we'll see you next time.